the second type of probability we can calculate with the counting methods is something where we don't have replacement. And these are going to be things like when you're dealing with decks of cards, once you take a card out of the deck, it's no longer available, so it's without replacement. So here's a simple example. What's the probability of drawing 2 aces from a standard deck of cards? What would be the probability of drawing 2 aces? So let's use the counting methods to solve this. Again, there's more than one way to solve this, but we're going to use the counting method here. So what's the probability of drawing 2 aces? So again, we're going to make our denominator all the possible outcomes, and we're going to make our numerator all the ways in which you can draw 2 aces. So I'm going to start with the numerator, and literally I'm just going to write out how many different ways can you draw 2 aces when you draw 2 cards from a deck, and I've literally just drawn them out here. So you could get ace of clubs and ace of diamonds, you could get ace of clubs and ace of hearts, you could get ace of spades and ace of hearts, and notice that I am counting it differently if it's ace of clubs and then ace of diamonds versus if it's ace of diamonds and then ace of clubs. So we're considering order in the numerator right now. We're considering the order. The order matters. I'm counting it differently if they have a different order. I don't have to do that to solve this problem, as we'll see in a minute, but if I count order in the denominator, I've got to count order in the numerator and vice versa. So for this first iteration of solving this problem, I'm going to consider order. So that's the numerator. There's 12 ways you can draw aces, and literally I've just written them out. How about the denominator? The denominator turns out that there are 52 times 51 different 2-card sequences that you can draw from a deck of cards. And again, I'm considering order here. And why is that? Where did I get that? Well, you can again draw out some kind of tree, just like we did for the dice. So the first thing that can happen is I can get any one of 52 cards. Let's say that in the first card I draw, say, an ace of hearts. Okay, if I draw an ace of hearts, then I can enumerate all the possibilities that are left. Well, once I've drawn that ace of hearts, there are only 51 cards left. I can no longer, the ace of hearts is gone. So now there is only 51 choices. So if I draw out all the possible 2-card sequences, once I'm on the ace of hearts branch, then there's only 51 possible things that can happen after that. So we start with 52 branches, but whichever branch you go down, the next node is only going to have 51 branches. So you start with 52 choices, but then because one of them has been lost, it's been pulled out of the deck, there's only 51 left next. So the total number of different 2-card sequences you can possibly draw, is going to be 52 times 51. And notice again that if you look at all the branches that will come out here, the ace of hearts followed by the ace of diamonds will be different, a different branch than the ace of diamonds followed by the ace of hearts. So again, we're considering order here. So the denominator will be 52 times 51. Then we can just divide the numerator by the denominator to get the probability. So the probability that you draw 2 aces, when you draw 2 cards out of a deck, is 12 divided by 52 times 51. So that's one way to solve this problem. Again, it's not the only way. We can also try to solve the problem ignoring order. And a lot of people feel like, oh, why should the order matter? It doesn't matter for the hands that you have in a card deck, so card game, so let's ignore order. So we can solve the same thing ignoring order. But if we ignore order in the numerator, we've got to ignore order in the denominator. So if I ignore order, I can write out that there's 6 possible different pairs of aces when I'm not considering order. So my numerator will now be 6. For the denominator, the only way to get rid of the order is simply to divide out the order. So I'm literally going to just divide by 2 here because there were 52 times 51 different 2-card sequences. If you want to divide out all the repeats, you just have to divide by 2 here. So then the denominator becomes 1326. So we can divide the 2 of those, the numerator by the denominator, to get the probability. Of course, it's the same probability that we got when we considered order. We are hoping to get the same probability no matter how we approach the problem. I'm just going to throw in that there's one more way to solve this. As you can see, probability is tricky because there may be multiple ways to get the same answer. So here's another way that you can get the right answer. And this way is probably the way that most people find the easiest, but it's something that we're going to be talking about more in Module 2 than in this particular module. So this is not a counting method, but rather you could just say, look at it this way. What's the probability of drawing an ace on the first draw? Well, that's 4 out of 52. We calculated that before. So you can calculate that probability, and then you can ask, well, now that I've drawn an ace on the first draw, what's the probability of drawing an ace again, a second event? Well, once you've drawn one ace out of the deck, now you're down to 51 total cards in the deck and only 3 aces. The probability that you draw an ace on the second draw as well is now 3 out of 51. It's different because something already happened. You could say the probability of drawing an ace on the first draw is 4 out of 52. The probability of also drawing an ace on the second draw is 3 out of 51, and we can just multiply those together because in probability, and means multiply. So the probability of both of those things happening, to calculate that, you're going to multiply those together. So notice that when you multiply those together, you get the same exact probability as we got before, 12 divided by 52 times 51. So it doesn't matter which way you approach this, there's multiple ways to get the same answer. And again, we're going to talk more about using this multiplication rule, multiplying probabilities together in Module 2. This is technically not a counting method that we've done here.